Okay, here we go. This is part 2 for chapter 10, section 2 in Algebra 1. So I'm going to stay on this one screen where I ended on the other video and just kind of go back over it a little bit more because I went through pretty quick. There's different ways to do this. I'm kind of trying to understand or use your understanding of number sense and hopefully remembering some vocabulary rules. Or not vocabulary rules, but exponential rules, and be able to kind of work with you guys that way. Once you kind of look at radicals, you could do these a little bit differently, but I'm trying to stick with one way right now, and kind of hopefully we'll build on that as we go through. So I multiplied everything up like I said before. Then I look for perfect squares. I used that also for the numbers and also for the exponents, and then took the square roots of those. So like for this first one, 98 broke down into 49 and 2, and then the square root of 49 is 7, and 7 times the 6 gave me the 42. The x squared, I could take the square root of, and that gave me just x to the first. But then I had these other radicals that I couldn't do anything with, so I went back and I just put them together. That's simplifying everything, okay? So that's kind of the explanation for that. This one down here too, 6 times 18 gave me 108, and I knew that 36, sorry about my writing, is a perfect square that multiplied to 3 gives me 108. So the square root of 36 was 6. And then 3 times 16 gives me the 18, and that square root of 3 I couldn't do anything with, so I left it in the radical. Okay, so that's kind of what I did here. This one at the end kind of comes out a little bit without a radical in it. 5 times 20 gives me 100. X to the first right here, and x to the fifth is what gets me x to the sixth. And I can multiply the numbers outside just like regular old coefficients, so that gives me the 21. The square root of 100 is 10. The square root of x to the sixth is x to the third, and I was able to just kind of multiply everything together. Okay, so that's how you do those. Get good at those. Make sure you practice those on your assignment. Okay, go back to your notes and look at it. Some of you guys are really good with your numbers and understanding it. There's different ways to do those, and I might get to that point at some time with you guys. Okay. The next one, I'm going to skip the quadratic formula one. I'm going to do a separate lesson on that a little bit later. So I'll put that out there when I feel like it's appropriate for you guys. Okay. We skipped the quadratic formula from chapter 9. And it's showing up here. We're going to do something with that. I'll do a separate thing. Okay. So going here, we need to simplify radicals. This was the second kind of definition on the beginning of the note. So on this one, there's a math rule. It just says you can't have a radical in the denominator. It makes the whole thing, the definition might be irrational, and we can't have that in math. So we need to fix it. The rule to fix it is that whatever the radical is, so in this case square root of 7, I'm going to multiply it to itself, but math rules also say whatever you do, in this case to the denominator, you have to also do it to the numerator. Okay, so I had to multiply both top and bottom by the same square root of 7. 3 times 7 gives me the 21. And square root of 7 times the square root of 7 is really the square root of 49, but what's the square root of 49? It's 7. So that's how I was able to fix that fraction. It's okay to have a radical on the top, but not in the denominator. Okay, so come back over here, and on this question right here, I got a radical in the denominator. I got to get rid of it, so I multiply it by itself. And so on top I get, 7 times 8 is 56, and that x is there also, so square root of 56x on top. But square root of 8x times the square root of 8x just gives me 8x. because technically it would be 64x squared, but when I take the square root of that, I get this, okay? So what I want to do is make this simple. All I need to do is take the square root really away from the denominator when I'm multiplying it to itself. And we talk about this in geometry next year. When you multiply a radical to itself, like the square root of 7 times the square root of 7, you just get 7. Okay, so let's not overthink it. Let's simplify our rule. I'm going to multiply it to itself, I get that number. Or just take the radical away, but I still have to do it to the top. Okay, so that's what this little thing is down here. I'm multiplying both together, so I just get 3 on the bottom, but 2 times 3 gives me the square root of 6 on top. And then we have another example again. Remember that radical really goes to each the numerator and the denominator. So I'm going to multiply it by the square root of 3 top and bottom, and that's what I get from that. So that's a simplification of having a radical in the denominator. Okay, really important that you get that down. Make it easy to understand. It shouldn't be that hard for you guys. And when you're multiplying radicals, it's just like regular old numbers, so don't get hung up on that either. I know it looks funny, but make it easy. Okay. On your section summary, we want to simplify radicals in the denominator. And by multiplying the top and the bottom by the radical. Okay, so that's going to be some practice, and I'll just let you guys know I get a lot of freshmen that come into geometry, and this is one thing they feel like they never really were taught in 8th grade. So, and then they come into geometry and they have to have it and they don't know it. So we got to spend time reteaching it. So really important you guys get this down for geometry. And, I don't know where we're going to be, but we might need to reteach this next year when you guys come back, if that's what happens for this school year. Okay. So practice this a lot in your assignment. And if you got questions, make sure you email me. Okay.